array, all plate. I'm going to want to get this out of the way for now. Who knows if we'll be able to revive it. Okay. So let's say we've got this so we have a date, and it's stored as an integer number of days since some Sunday way back in the past, right? And so we need the day of the week, and we think, oh, 7 days in a week. Whenever we need it, we just take this date and say date mod 7 is the day of the week, right? Easy, just a single little, so, we're in a modulus, this is modulus in our language, right? So that looks simple, right? It's just this one little operator. I suggest that this is very problematic code. Why? So maybe the dates, we're using the system date, or maybe we've got a date library for our language that gives us some format for the dates. Maybe we wrote our own date class. What's the problem? We've set ourselves up, too close, huh? We've set ourselves up for maintenance problems and bugs down the road.
Wait, so do you have 3 functions that do the same thing?
Well, somewhere in the function, right? So we have code, right? Some code, and then we happen to need the day of the week, and we do some more code, and then we return something. So these lines are in this function. We've got some code, right? And then we do some more stuff, and we return. Just in various places, we need the day of the week, and we put this line in. So let's see if Sabrina has...
So what's wrong with that is that you have like the same kind of logic in 3 different places, and if you need to replace it for some reason, then you might miss it in the other function, and it's better to have that function like somewhere else in one place, and then you can apply it to all 3 in case you need to make changes later.
Excellent. Don't repeat yourself. That's the principle. This is a little catchphrase, but it's handy. You get the reason we can use these catchphrases, they can be handy, is they give you a simple way, a simple thing to hang this idea on. Sabrina is absolutely correct. Let's say that our system says, Sunday, January 1st used to be the first day, but we now have customers who say we need dates back to 1900. We're moving the first date in the system, which now happens to be a Tuesday. So day mod 7 is now going to be off by 2, if you had this, right? Or they say, we used to store an integer number of days, but now we're actually storing the number of seconds since some date because people need more fine-grained stuff. Now mod 7 is nonsense, right? It's complete rubbish. So what you do is you write day of week, and you pass in, if we're writing C++, somehow you pass in the day, and hopefully you have a way to get that, and you return day mod 7 if this is the state of your system. But then when that changes, you change it in a single place in that function. So even though this is just a single date mod 7, you think, God, why do I need a function for that? Carol, you can put your phone away, please. Thank you. Why do I need a function for that? That's stupid. It's just mod, right? It can change because the date format might change. And if you give people this function, they don't need to even think about mod 7. I just call this, and the system, whoever's supporting the library, they're responsible for keeping it correct. And a lot of languages, like C and C++, would optimize this function out of existence when you compile it anyway. The code would wind up going straight in line. Advanced compilers will often see that if a function is small, they'll lift it right in line. So in your source code, it's a function call, but in the actual compiled program, it's just directly inlined. So you don't even lose speed. But frankly, worrying about the speed of a function call as opposed to the maintenance of your program is a foolish worry about optimization. You're going to spend you worry about optimization if you have an n-cubed algorithm and when you could have n-squared and you have a lot of records. Then it's worth worrying about it. A function call, unless you're writing like the real-time braking system for a car or something, this little tiny extra overhead of a function call is nothing. When we're the kind of things we're writing, a newsletter manager, a website that shows emergencies, an agent-based modeling system, this tiny, tiny overhead is nothing. What you want to do, you almost always want to focus on optimizing the maintainability of the program. There's another Donald Knuth. Donald Knuth is probably the most famous computer scientist alive still. He wrote The Art of Computer Programming, these thick books. Somewhere around 1995, he deleted his email account, and he hasn't been on email since. So the most famous computer scientist in the world does not use email, interestingly. He said, it's a pain in the butt. I got all this nonsense mail. If people really want me, they write me a letter. But he said premature optimization is the root of all evil. That's probably an exaggeration. Meant all evil in code. I don't think he meant Hitler. Premature optimization was responsible for Hitler. Right? That's not what he's saying. In code. And that may be an exaggeration, but he's making an important point. You don't try to optimize a program until you find out that there's actually parts that are too slow, right? And this is a big advantage of putting out actual usable software. Quickly, the user will tell you, hey, I click on OK, and it takes 20 seconds. That's really bad. Now you know where to optimize, right? So you don't try to write really fancy code to make things fast before you know there's any problem. Okay. Where's erasers? That looks pretty grim. That's not so bad. Let's do. So you're writing some software for NYU, and you know that there's 14 weeks in the semester, right? And you want to calculate how many lectures there are going to be for some reason. So you write this code, total lectures equals lectures per week. So for each class you have this information. It meets once a week, twice a week. Lectures per week times 14. You go, great, and you check it out. And calculation works well. There's still a problem. What is wrong with this? We should at least name it as a constant. So because when NYU and Poly merged, I think NYU had 13 weeks per semester. And then when they merged with Poly, they said, well, Poly has 14, we'll go with theirs and we'll do 14. There are requirements, but these things change, right? And if this 14, if it's in one spot, it's bad enough because it's not really clear what it is, right? Someone could figure it out. They can take a guess and say, I guess that's the number of weeks. But it might even be the case that you don't even want it as a constant. That's better, all right? Because now the meaning is clearer, right? Can you clear that chair? Yep. Thanks. Yeah, thank you. Okay, we did a little bit of project discussion to start, so make sure you catch up with me at the end and we look at what project you're on. And
Sure.
Yep, super. But now, all of a sudden your user says, well, hey, what about the winter semester? There's only 4 weeks. Or summer, it's 7 weeks or 6 weeks or 14 weeks. How would you handle that now? That's a general technique. We need to multiply. So one thing people tend to do is if semester equals winter, right? Imagine we have some constants. Else if semester equals spring, right? Else if, that's one way to handle that, right? And you fill in a number, maybe you have a constant, weeks for spring semester, weeks for summer. This code is fragile, it's long-winded. There's a principle here that whenever you can, you should drive logic into data and not have extensive if cases like this. Here, the right solution, right in that it's very easily maintainable, is in your code, or better yet, even on disk, in like a JSON file or something, have a structure like this. So we have a dictionary, right? Do this, right? And you put this in a JSON file or a CSV file. They can even have an administrator, can't program at all, maintain it. When the winter semester changes to 3 weeks, they just go in there. To them, it looks like an Excel spreadsheet. They go in, they change 4 to 3, and your code just works, right? No, there's no changing any logic. If we get a new semester, now we have the mid-fall semester. I don't know what that is, but it's some special 2-week semester where they have to go 24 hours a day for 2 weeks in the fall. Who knows, right? You just put it in and put the new number in, and your code works, right? There's no need to add a new if, right, that says handles the mid-fall. So here's a general principle, which is whenever you can, drive logic into data instead of leaving it in your code. Tirapal, can you make a note on that one? Right. Structuring. So, this is a review of the first module, and I just want to, we have these things kind of as brief notes. I want to expand on them a little because one thing that's important to stress, so these are basic software engineering, software maintainability principles, right? One thing that we want to stress is that none of this goes away because now we have some DevOps tools. All of this is still applying. We want to make our software as maintainable as possible so that we can rapidly make changes, and the old things that help do this are still around. So I should generate an example for this. But I sometimes see a program. We wrote a program to automatically convert a Python model in the agent-based modeling system into a notebook, Jupyter notebook that could run the model. And the original version of the code, we had main, and then we had get includes, and this was like 20 lines. No, maybe not. Let's say 16. And then we had setup, constants, and globals. So there were some comments like this, and then there was like a dozen lines, and then we had code that said perform setup, and there was 20 lines. This code, each of those comments, the person rightly saw that these were major divisions in the code. Each of those comments should be the name of a function call. And then your main reads like get includes or imports in Python, right? Setup constants. Perform setup, perform model setup, something like that. Now you look at this function and it reads like a specification of what the program has to do. It's just a few lines and it's an outline. You want your program to look like it's an outline of what's going on. And then in here, maybe this, it's broken down into read the include section, parse it and get it in, and then perform the actual imports, right? Something like that. So make your function short. When you hit 20 lines, you should be starting to feel pretty itchy that this function is actually should be several. 20 lines, you want someone to be able to take in the function at a glance. Even 10 lines, the average function in your program should probably be 5 to 10 lines. Sometimes it makes sense to extend one to 20. When you write an 80-line function, you've gone way, way too far. There's no way you should be having functions that long. Formatting and indentation is important for readability. The reason Python made formatting syntactical is that Guido von Rossum was so sick of seeing bad formatting, he said, darn it, I'm putting it straight into the language. They can't even run their code if it's badly formatted. For names, I've seen people who, this function would be called set up constants and globals so that the model we're building will be able to run. That's almost certainly too long. For one thing, Python has a standard line limit of 79 that should be followed. It's in the Python standard, formatting standard. Professor Sterling for his C++ class enforces same kind of thing. Short lines, think about this. When you look at the newspaper, you get the New York Times, right? Does the story run straight across the page? What do they do? It's in columns because our eyes are better at doing this. Newspapers have been around for centuries. They know, right? We're better at reading something if we're just scanning short distances of text. We're not good at going like that. So long lines are less comprehensible. And when you go and you put them on an overhead display, the resolution's probably bad and you can't see it. Or I look at code on my phone a lot, right? Long lines aren't going to really do well on my phone. So extremely long lines make it very hard to break because you can't break in the middle of a function call name, right? So on the other hand, you don't want to name this SC either, right? You might be set up consts. That's probably fine, set up consts. This, probably you could go with this, get inks. People, there's certain standard shorthands. Inks or includes, consts or constants, right? Perf model setup, and model might be MDL. The key is you want to write enough that the user can figure out what the function name means and not anymore. Don't try to stuff the entire details of the function into the function name. Test as you go along. This is extremely important and extremely hard to accept. It took me a couple decades to really convince myself that I would actually go faster by testing every couple lines I write than I would by writing a lot, because I felt enthusiastic, so I'm just going to write, I code everything. And then I found I had 15 bugs, and it was hard to find them because I had written a whole bunch of lines. Test-driven development, you actually write a test. If you really follow the discipline, you write a test before you're allowed to write any code. And then you write code that passes the test. And in fact, you do minimal tests. You write just enough tests to make the test fail, and then just enough code to pass it. But you can achieve much the same effect if instead you just write tests immediately as you go. Certainly you want to try out your code as you go along. The last thing I want to mention is this, and this is something that's important as we do things like build API servers. Okay. Well, let's look at the agent-based modeling system. Well, let's see if we can get our display back, and I'll show you this. Okay, it's going to warm up for a while. The agent-based modeling system. We have a model. And right now, at present, we can run it from We'll see if we can get the display back. But at present, it runs the same model with no rewriting of the model code. Runs in a Jupyter notebook. It runs on an API server with a React front end, and it runs from the command line. And not only does it run in all those ways, when we did this, it took, the fellow working on this took, 5-6 days to bring up. He wrote something to automatically generate notebooks. Given the model file in Python, we now have a script that'll make a notebook and run. If people know what Jupyter notebooks are, is anyone not familiar with it? Okay. So we can automatically do that. Why was it easy? Because when you want to divide your code into functional parts that are coherent and then have the narrowest possible interface between the parts. So what each of these parts need to do is be able to call setup and then run. Basically, that's it. So they interact with the model through two calls. One to say set up the model, and then another to say run it. Why is it two calls? Because we might want to run it 5 times and then 10 times, or we might want to stop and graph it so we can do a scatter plot also. But the models were built so that there's a narrow interface to interact with the model, and that interface knows as little as possible about who is interacting with it. So, for instance, instead of writing, we had the command line version first, and we could have just done print, hello model user. But then when we're on an API server, what's this print going to do, right? We're running API servers. Who knows what an API server is? Okay. So API servers serve formatted, instead of web pages, it's like a web server, but when you hit a URL, instead of a web page, it's serving formatted data that then the person who receives it can do anything with. They can turn it into a web page, or they can display it in an iPhone app, or they could have a program reading it and automatically processing it. So it gives you much more flexibility in your user, much more flexibility in what they want to do with the data. People would write web scrapers, they'd scrape web pages to get data. Now that people are writing API servers instead of web servers, you don't need to do that because it's already coming in as formatted data. And it's easy to put it up in a web page. So the API server, but it can't, we print to the screen. The screen is probably not even a screen attached to the server. So what's the print supposed to do? So we didn't write that. We wrote something called tell user. And for the command line, tell user was just print. And if you looked at the code at that point, you might have said, this is stupid. Why don't we just write print? Why are we writing tell user? Well, because what we do when we wrote the API server, we wrote, so it's user.tellUser, and we have different types of users. When we wrote the API server user, that user collects the data in a big string and sends it back in the formatted data. So by making a narrow interface between the model and the user, so the model isn't trying to interact with the user randomly in all different ways throughout the model. Instead, there's just a couple of function calls that the model uses to talk to the user. We have a narrow interface between different modules. So the user is an object, and the model doesn't know anything except the fact that it's got a user object. It's a different type of user object for running automated tests. Because once again, you can't tell the automated test something. What you could do is log it in a file, though, if there's something that has to be noted, right? So this allows us flexibility to mix and match modules. Let's see if we can get this up. In the meantime, 11:53. Lovely. Okay. Well, we're still having problems on this machine. All right. So we'll skip the demo. I'll show this next week. Okay. Let's go on to this. I now want to do a little tour of Git. And for this, you should bring out your laptop and okay, so if you don't have a laptop, try to follow along with your neighbor if you can. That would be excellent. So if you'd share. So I am going to clone a particular repo from my GitHub account. I picked one that I don't have yet. If you're not on this project, you could clone this anyway. But it might be more useful for you to clone the utils project. I'll show you that. What just okay. So here, gcala utils, you can work with this one. I already have that cloned, so I'm not going to clone it again. So we've got a button here for clone or download. I'm going to do everything from the command line, which you should be at least capable of going and working with Git from the command line when needed. GitHub Desktop looks like a fine product to me, but it can't do everything that you can do from the command line. Sometimes you're just going to need to be able to go in and patch something up from there. The other thing is when you want to put this into scripts, you're going to have to use the command line versions. You can't put the mousing and clicking on things into your script. So when you want to automate this, you're going to need to be able to work from the command line. So we clicked on this to get the URL that we're going to clone. I'm going to go back to my directory, cd changes directories, and I'm going to do git clone. Okay. All right, this got. Okay, so the next thing I want to take note of is the fact that we're using Git submodules. This is a directory full of utilities that we'll use across all projects. It shows up as 2 folders with an @ instead of like a normal folder does. This means this is a separate module that's included in this project as a submodule, a separate repository. So we look at the command line and we see it's empty. So there's commands for working with submodules. Oops, so we have to run init first. Okay, and now we can run update, and now it fills it up. And now when we look at utils, it's filled with the proper files. Okay. So we've cloned. Let's add something now. Okay, what's in here? We don't have a make file yet. Let me just give you a little sketch of, it's important to know the structure of Git to understand. You can learn these commands mechanically, but if you don't know the structure of what you're dealing with, it's not going to make nearly as much sense. So Git was built for the Linux operating system. So Linux has thousands of developers worldwide, and Linus Torvalds, were previous version control systems, but Linus Torvalds didn't like them. In particular, they required you to have access to a master repository in order to work. And people were, wanted to work on Linux while they're out in their cabin in the woods with no internet. And so he said, no, I want the repository itself distributed. So we're using GitHub. You could use Bitbucket. Git is not tied to GitHub. There's another thing called Bitbucket that does the same thing. Many companies run their own internal GitHub, as it were. The basic idea is that there's a repository, which usually is shortened to repo. And everybody who's working has a full copy of the repository. So this is me, this is you, this is GitHub. GitHub is just a way to coordinate our copies of the repository. What we have besides this is we have a working directory. So when you get the repository, what you're thinking is the repository is actually just your working directory. It's your working copy of the files. The actual repo, oh no, we need ls minus. So that's a long listing. That says list all. This file, .git, that's the actual repository. And if we look in there, we see the configuration of the repository, any GitHub hooks, the branches, a description, the actual objects. So this is the actual repository. What you're working on is just a working space that has, it's got the last version that you committed to or you pulled from somewhere else. So this has your current files. When you want to make a new file, let's copy our make file over from What's a simple make file? Utils should have a simple one, right? I'm just grabbing a make file from somewhere else so that it has some content to work with. It's usually easiest to start that way. A make file is directions on building a program. We should Docker, Python files. Okay. This will build HTML test, script test, PyTest. I'm just looking at what we have here. Probably it's pretty similar. We don't need PowerShell. We'll do lint. Yeah, this looks perfect. We probably should put lint even in our tests. So we're going to use make files throughout the course. The structure is there's a bunch of setup of variables just so you don't repeat yourself, so that when you want to mention this Docker dir, you don't hard code it again and again. So this directory occurs once. Then the basic structure is there's a target, so we can type make container or make HTML tests or make script tests, and the target depends on these files, a Docker file and a requirements file. And then if the target is out of date with what it depends on, then this command will be run to build the target. So we do docker build -t. That's just a quick mention of what the make file is. We probably don't need script tests here. So we'll eliminate that. And okay, so I just put a make file in this directory. What this means is that make file is here. It's not in the repo at this point. This is just my workspace. To put it into the repo, what I have to do, and you can do this with your repo, you can add a test file or something like that. You don't have to be adding the same file as me. Git add make file. This now adds it to the repository. It's now registered with the repository as a part of the repository. We want to do this because almost any project typically generates a lot of cruft, a lot of, my editor generates temporary files as I'm working. We don't want those checked into GitHub. Often your program will write a log file as it runs. We don't need the log files checked into GitHub. All sorts of temporary stuff that gets generated you don't want in GitHub because it makes for clutter, right? It makes it hard to understand what the essential parts of the project are. We should know the command git status, which tells us what the current state. This is going to do an informational report on. It's going to look at our working directory and compare it with the repo and see what's the state of affairs right at this moment. Well, we have a new file that's a change to be committed. So right now, Git knows that this file is intended to go in the repo. It hasn't yet been committed. It's still just a working copy out in the red area. So we're going to need to run a commit in order to get this new version into the repo. It also says there are untracked files, makefile tilde. We want this untracked. We can, in fact, inform Git that, let's see, we'll make we can say star tilde should be ignored. So git ignore tells Git what things we're not interested in. Okay, so we now no longer see makefile tilde as an untracked file. And this is handy because you can build up long lists of untracked files, and there's something in there you really did mean to track. And if you're leaving this list getting longer and longer, you're going to miss the fact that, hey, there was a file you were supposed to add, you forgot to add it. It's a common problem. You start working on a file and you create a new file, edit 10 files, and you do a commit and a push, and you think I'm all set, and the server breaks. Why does the server break? Because you forgot to add the new file, and it's part of the server now. So you can do git status and see that you have untracked files, but if you're letting them pile up with things you don't really want to track, you're going to miss the key one that you did mean to track. So the .git ignore is crucial for keeping that listing clean. It's important to note if you're using like the Mac Finder or something, and you're looking, you say .git ignore, I don't see any file like that. In Unix-based systems, files that begin with a dot are system files, and for instance, the Mac Finder will not, by default, show you these because it considers that you're just a user who will probably screw things up if you ever get your hands on these files, so we're not even going to show them to you. There is a way in the Finder to turn on the visibility of dot files. It's interesting, if you look at your home directory, you're going to see like 40 new files you didn't know you had if you turn that on. This is the file that runs when you log into your Mac that does a bunch of Unix commands, and you can put in things like aliases. If you're on the command line, if you simply type ls, you don't see any of these dot files, right? They're hidden. You have to add -a to show all. So we now see .git, .git ignore, .git modules all show up. Your home directory is even going to be more littered with these. But it's good to know that these dot files won't appear in the Finder or in ordinary ls, or else you can be very puzzled about why don't I see it? The professor said this would be here. So we now made a change to the git ignore. We have a brand new file called makefile. And what we want to do, we're happy with our changes to these. And we want to put these, these are sitting out here. We now also have a change.git ignore. And what we want to do is transport them into here. So we want to put our changes in. There are several ways to do this. One of them is I can type the names of the files, and I can commit just the files I want. If you know that there's some file you have that's working, and you want to get that in and recorded and make sure you don't lose the changes, there's another file you don't have it working yet. It's very good to commit just by a file name. In this case, I'm fine with everything going in. I can do -a for all. That commits everything that's new. Now you have a choice. How many of the people in the room have used Vim? Okay. If you know how to get in and out of Vim, you don't need to put a message on the command line. Vim can be a little one of the things is, if you want to torture new Unix users, get them in Vim and see how long it takes them to figure out how to get out of Vim, right? It can be a little daunting, and if you don't know how to do it, the best thing, and it's not a bad practice in general, just put a commit message on the command line, right, with -m. This is typical. Unix command line tools work by taking a common pattern now is that you've got one thing like Git or Docker that is like a control module for a whole bunch of programs, like commit and push and status, right? And then, so the second thing is really the command you're trying to run. So Git is like our control module. It's got a bunch of things: add, commit, push, pull, status. And then it takes flags that modify the working of commit. This flag says commit all. This flag says here's the message. So this is a very typical pattern now for command line tools. You're going to see the same thing when we learn Docker, that we have Docker and then some particular Docker command and then a bunch of options for how that Docker command is going to work. Commit messages. Sometimes I see people write a commit message like, made a change. Well, yes, that's why you were committing, right? We know that you made a change. Otherwise, what would you have to commit, right? Don't make a message like that. We're working in teams now. You don't need to write a book. It can be quick. What's the purpose? What your goal is to let your team know what's going on, right? You need enough of a message because a few people do a commit and then something breaks. Well, what you want to do is find out, geez, what work could have broken it? And so you look through the commits. And if each commit says, made a change, made another change, some new code, you don't really have any idea who to go to, what to look at as to what broke something. However, if you write something like added makefile and star tilde to git ignore, then people can say, oh, okay, we know just what went on. It wasn't anything elaborate, right? We don't have to say, you're not trying to write a book, just enough. So someone who is looking for a problem here can say, well, Professor Callahan's commit, he just added a makefile and changed the git ignore. He couldn't have broken any Python code doing that, at least if the message is honest, right? So I don't need to look at that commit. That's not where the problem is. If someone says, hey, I was messing with the main server file, trying some new options, and the server broke, well, that commit's probably a good place to look for why the server broke. Okay, so what we have now is that this is now in our repo, and if we do git status, what we see is we don't see any changes that aren't committed, but we see your branch is ahead of origin master by one commit. Although these repos are all peers, one of them can be designated as the master. And typically we make the GitHub repo the master. So this is the one where we're going to coordinate our work through. We're not going to go directly from your repo to my repo. We're going to coordinate work through the GitHub master. And that's what the GitHub master is serving. It's the coordination point. So your work and my work, how do we share it? We don't pass it directly to each other. We go through GitHub. But we just made a commit, and the master repo does not have that. And we could have a look in, if we refresh the page here, we will see that we have an old git ignore from 8 days ago, and there's no makefile. So now we run git push origin master. I don't usually use this machine for development, which is why we've hit some little snags here and there. It's usually just my lecture display machine. You can record your username and your password so that Git won't ask you every time you do a push. So let's see if, what? That's interesting. I mistyped something. Terapal, could you look up what the command is to set your local username for Git? Yeah. That's, you use, there's different levels of things that you need to know when you're working as a software engineer. The stuff you use every day, you're going to memorize it just by using it every day. So, I know the flags for commit because I use it multiple times per day. Setting your username and password, you do it once every few months. So that kind of thing, you have to know it exists, but you don't have to know the command. Yeah. Git config. User. Okay. Let's try. Yeah, it's up to date. Let's change something here. Bash to PS. We don't need that. We're not using PowerShell in this project. We'll delete them. And let's commit it again. So now we'll do a commit by the file name. I'm also happy to go very fast here because this project is just starting. I can't really break anything because there's nothing working yet anyway. So I'm being rather casual about committing new files because in a project where nothing works, you can hardly break anything. So took out PowerShell variables. So that's enough there. And now if I push, okay. It did not ask me, I thought it was going to ask me for my password this time. Maybe because I had just done it. But in any case, you can configure this. That's up to you. If you don't mind typing your username and password every time, don't worry about it. If not, there is a way to store it so that next time you do a push, you'll have it. Let's go look at this. Generally speaking, we don't make changes directly on GitHub, but we can. So I'm going to make another change here. Let's see. Data dir, test data. We probably should, this should be requirements dev.txt. We keep all the dependencies for our project in requirements files. We started out using it for Docker, so we store them in a Docker dir. We will we use them in more places now, but that has just been our standard for where to put them. So we're going to say our commit is added dash dev to requirements file. And we're going to commit the changes. Okay. And now if I do git status, I thought it would tell me I was one commit behind. But if we want to get the new code, we do git pull origin master, and we have our new makefile locally now. So we'll end off in maybe 10 minutes or so. Yes. the next two commands are very important. When you want to move things around, so let's do this. I'm hunting for what the best example to use here is. Student oop. I guess we'll use Indra. So Dockers with lowercase. Okay. So I'm going to make the Docker directory. So I'm going to move the requirements files from Indra into the Docker directory here. Well, let's move them here at first, and we'll show you. Okay. So we just grabbed these requirements files. Let's take a quick look at what they are. So this says this project depends on Jupyter, Flake8, Coverage, Nose, Selenium, Erlib3, propargs. This is wrong, actually. Someone has put some things in here that should be in requirements dev, not requirements. The only one we need this. Let's see what's in requirements dev. So these are Python packages. So this. I copied them both together. That's what happened. That's the problem from my copy. So let's do this one at a time. Okay, that's better. Okay, so this is requirements dev, which is some testing tools and some code checking tools. Proparg should be in requirements, not, well, we don't need it for this at all. Still the same. Well, so there's a problem in the other project that I know what happened. It was my original copy. Cat, Docker. Yeah. They're both requirements dev now. Git stash. Here's another command. When you've screwed up, you can stash your work. My first copy attempt failed. I copied one file onto the other instead of copying them both over to our directory. So I am going to stash my work and pull again. Okay, no. Let's see what we have in the Docker directory now. Cat, Docker, requirements. This is better. Okay, now they look different. So let's go back to where we were. So I messed up the copy command, which actually copied one of the, I was trying to move two files from the other project into this one. Instead, I copied one of them onto the other. So they were identical. So to undo that, I did a git stash, which says whatever what's stash doing? It's taking whatever you have in here and tucking it away in some stash part of the repo. You can always get back to it, but it says, whoa, what the work I was doing here, I screwed up. Stash it away, and now set things back to before I started working, to my last commit. So this gives you some insight into what this working directory, how it relates to the repo. What you're doing here is not in the repo, not until you commit. So I was working, I messed things up, but I hadn't committed, so I can do a stash and say, put aside my current work, and now the repo is back to the state of my last commit. So now let's try copying these properly. Okay, we'll just do one of these files for now. Okay, so we have requirements.txt here. And this is a few things we're going to need to be able to run this program. Probably I don't need, well, we'll leave Seaborn in for now. So these are some Python packages I'm going to want. So what I have to do first, I can do git status. We now see requirements.txt is an untracked file. Git add will add it, will register it with the repo. And now I can commit it. And we're going to do -m first stab at requirements file. Okay, I've now committed it, and now I realize, oh wait, all the other projects I put the requirements in the Docker directory. Here I put it up in the top level. I probably should move it to Docker to be consistent. You can easily make a mistake here and just drag the file in your Finder or do an mv command. Git has its own mv and rm commands, and you've got to use them so that the move of the file is registered for the repo. If you simply move the file using your operating system and not using Git, Git won't know the file's moved, and you're going to have some trouble getting things back into a proper state. To Docker. So now we've moved it. Now we can commit again. And here we want to do moved requirements to Docker dir. Okay. We should push, so we have git, I did a move, but removing files is the same thing. You want to use git rm, not just drag them to your trash can. The last bit, let's just end off with a brief discussion of branching. So this is here because you for sure should know about it. Let me do a push so I don't forget. Probably could have typed it faster than scrolling all the way back here, but git push origin master. Okay. Git allows branching. So the repo will have a master branch always, but it could also have a new user interface branch. And people will typically branch new API endpoint branch. So people in many, many companies will work by signing each developer to make a branch, and they'll work on that branch for a couple weeks, and then at some point, you've got to merge the branches back together and integrate them to get a new release. This is very, very typical. You're going to find this in many companies you go to work for. I have worked that way. However, in general, we are going to follow the dictums of Jess Humble here. Okay, so this is Jess Humble's probably the top guy on CI, continuous integration, continuous delivery in the world. Continuous integration means that people are constantly merging their work with other people's. They don't wait several weeks to make sure the work fits with other people's. We did that throughout the summer, and typically when our work was developing a conflict, we'd find out that afternoon, right? You know, someone made a conflict in the morning, we'd know by the afternoon that people were heading down two incompatible paths. One of the problems with the waterfall model was that people were going on all these independent development paths, and they'd continue on them for months, and typically the integration phase would be a nightmare. It would take a long, long time. They couldn't make the modules work together. The whole idea of continuous integration is that you don't allow these divergencies to build up. So Jez Humble says, so it's not uncommon to see continuous integration basically ignored and people branching promiscuously, leading to a release process that involves many branches. And they have an example of multiple branches having to be integrated. The problem with this, unfortunately, fairly typical strategy is that the branches tend to stay in an undeployable state for large amounts of time. This violates continuous delivery, continuous deployment, which says the product should be always deployable. Furthermore, it is usually the case that the branches have soft dependencies on one another. In the example given, every branch needs to take bug fixes from the integration branch, and every branch takes performance fixes from the performance tuning branch. The branch for the custom version of the application is a work in progress that doesn't become deployable for an extended period of time. Keeping track of branches, working out what to merge and when, and then actually performing these merges consumes significant resources. Even after it is done, the team still has to get the code base into a deployable state. The exact problem that continuous integration is supposed to solve. In our model, new work is always committed to the trunk, to master branch. So, people who have been out on internships may find, well, geez, my company, everyone branched. They always had to stay on your branch till you got approval to merge to master or something. So I've done this both ways. I found that these integration problems Humble is talking about are serious. I have found that the risk of committing to master, if you have good automated tests, is minimal. Sometimes you break the product, but sometimes you break the product even if you've been branching. So in general, we won't branch. We'll work directly on master. And this means you're integrating your work with your teammates' work all the time. It also means you should make sure that there's been adequate testing done before you push your commits. I have been working this way for a couple of years and not found, people break a production server or something once every couple months. And when they do, usually we can just roll back a commit and fix it, and it's up and running. So the risk of these occasional breakages in a production server, to me, that's much less costly than the large overhead of continuously integrating branches that separated for a couple weeks, and then you're trying to pull them back together. If you're out on an internship now, if you go out on one, you may find your company does this branching. I say, and Jez Humble says, that they haven't fully adopted continuous integration yet. They don't really get the idea. That being said, I advise you to be cautious. Don't, as a new intern, announce to your manager who's been there 20 years that you don't really understand continuous integration, do you? You've got to, if you're going to bring up anything like this, you have to do it gently, and you can, at some point, the best point is when you see there's a problem. There's a couple branches that have gone on for a month, and they try to integrate them, and they're having a big headache. At that point, you can say, when I was at university, the DevOps professor mentioned this guy called Jez Humble, and he said that, sometimes people find it better to always work on master because you don't get these integration problems. So things will go over much better if you kind of gently bring it up at a point where it seems relevant. So that's my recommendation on that. But that's how we'll work. We'll work generally directly on master. Okay, that's it for today. Thank you very much. I'm meeting with the Docker people at 1:15, right? No, let's go to my office. Yeah, 370 J Street.